In this video, we are going to look at what an arithmetic series is, and hopefully by the end of it, you'll be able to realize how clever this Halloween costume was that Smeds and I wore a couple years ago. So let's start here with a warm-up. Write the explicit and recursive formulas for the sequence. Pause the video, give this a try. So hopefully you realize this was an arithmetic sequence. If I take any term and subtract the previous term, I would get that constant difference of -3. So every time I'm subtracting -3. Recursive formula should have that a sub n minus 1, saying I'm taking the previous term and subtracting 3. For the explicit formula, you should just have that n value where I can plug in whatever term I'm looking at to find the value of that nth term. If you distribute this out, you would get this bottom line. Now notice, this is going to be important today. If I'm looking at arithmetic sequences, if I distribute that -3 out, you really should get something that looks like y equals mx plus b, where that -3 is your constant rate of change, and this 31 would be like the a sub 0 term. So if I could go back 3 more, I'd be at 31. Now this bottom question here says find the sum of the first 7 terms of the sequence. So I've written the 6th and 7th term. If you add all 7 of these up, you should get 133. Okay, so that's not bad to do by hand. But if I ask you to find the sum of the first 70 terms, we'd be here a while. This really leads us into our topic for discussion today, which is a series. So if I add together terms of a sequence, that's what's called a series. So I simply am going to take any terms in a sequence. So here's a sequence. This would be called a finite sequence because I can count the number of terms. If I add together the terms of a sequence, that would be what's called a series. So I'm just taking a pattern of numbers, adding them together. That's what a series is. We also have infinite sequences, so that would be something that goes on forever. I can't count the number of terms. And an infinite series would go on forever. So today we're going to look at finding the sum of a finite arithmetic series. The sum of a an infinite series, excuse me. If I wanted to find the sum here, I mean this would go on forever. It would approach infinity. I couldn't really find the sum. So today we're going to really be focusing on something like this. There's a formula to find the sum of the terms of a finite arithmetic sequence. And in order to develop that formula, let's look at a little story here. There was a mathematician, very famous mathematician named Gauss. And when he was little, probably about 2nd, 3rd grade, the class was being unruly. So the teacher said, okay, add together the first 100 positive integers. So 1, 2, 3, all the way through 100. And the teacher thought this would take the class a while and it could buy her some time. And little Gauss, the boy genius he was, came up with the answer in a matter of just a few seconds. And he did that using a pattern. So I want you to think about how would you find the sum of the first 10 terms. And I'll tell you, if you add these up, the sum should be 55. So think of, is there any way that you could group these terms to come up with that 55 a little bit faster? Now maybe you're seeing what I've connected here. If I take 1 plus 11, or 1 plus 10, well 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, 4 plus 7 is 11, and 5 plus 6 is 11. So if I pair off these terms, I actually have 5 pairs, and all of them add to the first term plus the last term, or 11, and that would be the short way to get 55. Now if I look at 2, well 2 is 1 more than 1, but 9 is 1 less than 10. So 2 plus 9 also adds to 11, and I have all these pairs that add to 11. So this is the big equation for this lesson. To find the sum of a finite arithmetic series, I actually want to look at pairing off all the terms. So here's your equation. To find the sum of n terms, so n is however many terms you're looking at, so n is the number of terms. I'm going to take the number of terms divided by 2. So this here is going to give me the number of pairs. Just like on the last example, I had 5 pairs because I had 10 numbers and I paired them all off. A sub 1 is going to be the first term that you're looking to add from your sequence, and a sub n is going to be the last term. So if I apply this formula to what Gauss was looking at, in order to find the sum of the first 100 terms, 1 through 100, you take 100 divided by 2. That gives you how many pairs you'd have. You'd have 50 pairs of numbers. The first number in the sequence was 1. The last number was 100. So if you take 50 times 101, you would get out the sum of 5,050. And maybe you can see what this is doing. So I'm pairing off the numbers. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So I have 50 pairs of numbers that'll add to 101. Very quickly I can find that the sum is 5,050. Now if we look at the warm-up, we found the sum of these first 7 terms of this arithmetic sequence. So if I add together those first 7 terms, I get an arithmetic series. And we said that the sum should be 133. Well, I can use the same formula, so I want to sum the first 7 terms. Now people say, well, what if there's an odd number? That's fine. So if there's an odd number, I would still take the total number divided by 2. So this would be saying I'd have like 3.5 pairs. The first number in the sequence that I'm summing is 28. The last number is 10. So I would have 3.5 pairs that add to 38. So let's check it out. 28 plus 10, that's 38. 25 plus 13 is 38. 22 plus 16 is 38. And hey, this is half of 38. So if I take 3.5 times 38, that gives me the sum that I found on the first page. And this should very quickly allow you to find the sum of the first 70 terms. Now the only problem we might run into here is what's the value of the 70th term? So okay, if I'm using my formula, I have 70 terms. If I pair them off, I'd have 35 pairs. The first term's 28, but I don't know what the last term is. So now I'm going to have to do a little bit of work. So here's the explicit formula we found. If I want to find the 70th term, I take a sub 70. So plug in 70 for n. So negative 3 times 70 plus 31 is negative 179, and that's the value I'd be plugging into my formula. So I'd have 35 pairs of numbers that add to negative 151, and that should give me a total sum of negative 5,285. And let me emphasize, this equation only works if you have an arithmetic series because you have that constant difference. So for every 3 I'm losing here, I'm gaining 3 on this end, and that's why I can pair up the numbers. Now, instead of saying, oh, this is my explicit formula, and let's add the first 70 terms of this arithmetic sequence, I can abbreviate that by using the summation notation. So this is the Greek capital letter sigma, which means sum. So now, along with knowing what Smeds and my Halloween costumes mean, you should know what all the symbols on this shirt mean. And I can actually use that symbol to indicate to the reader to sum the terms 1 through 70. So at the bottom I put what term I want them to start with in the sequence. At the top is what term I want to end with. And this summation sign means I want to add up all the terms from 1 to 70 and everything in between. What sequence am I looking at? That's this right here. So this is essentially the question I was asking on the previous page, just using that summation notation. And your answer is negative 5,285. So now let's find the sum of this series. The first thing would be, I can only use that formula if it's arithmetic. So is this an arithmetic series? Sure it is. Do you see it looks like that y equals mx plus b? So if I took this sequence, if I'm not sure I can generate the first couple terms, so a sub 1, 5 times 1 plus 3, a sub 2 would be 5 times 2 plus 3, a sub 3 is 5 times 3 plus 3. Yep, I'm adding 5 every time. Now that I've determined that this is an arithmetic series, I can use that formula. So the sum should equal the number of terms divided by 2 times the value of the first term. Now careful, here I'm starting at 10. So I'd actually want to start at a sub 10 would be the first term I'm looking to add. And then I'm adding a sub 11, a sub 12, all the way up to the 20th term. So this is my first and last term that I'm looking to add. And the next question would be, well, how many terms am I adding? And be very careful. People always want to say 10. They say, oh, 20 minus 10, that's 10. Well, okay, 20 is 10 units above 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But I also want to include 10. So if you count from 10 to 20, that's actually 11 terms. So n would be 11. So 11 divided by 2, I'd have 5.5 pairs of numbers. The value of the 10th term, so 5 times 10 plus 3 would be 53. The value of the 20th term, 5 times 20 plus 3 would be 103. So I have 5.5 pairs that add to 156. Feel free to use your calculator. The sum of this arithmetic series is 858. Now don't memorize what's happening. Think about it. This is the 10th, 11th, 12th, and then from the other end, 20th, 19th, 18th term. I'm pairing these off. All of these pairs should add to 156. There should be 5 complete pairs that add to 156. The middle number, or the 15th term, which actually doesn't have a pair, would be half of 156, or 78. So I have 5.5 pairs that add to 156, giving me my total sum. Let's look at one last example. You borrow $4,000 for college expenses. You pay this payment back monthly. And you start at $100, then $99.25, then $98.50, and the pattern continues. So take a look at this, see if you can figure out the pattern. Each month, it looks like you're paying 75 cents less. So the first question is, how long did it take to repay the loan? Essentially, I want to know how many terms are in this sequence. If I want to know how many terms there are, you really need to start with writing the explicit formula. So think about, I'm subtracting 75 cents every time. This is an arithmetic sequence. Can you write an explicit formula for this arithmetic sequence? Pause the video, give it a try. So maybe you wrote something like this. If I want to get the 10th term, if n was 10, I'd start at the starting value and I would subtract 75 cents 10 minus 1, or 9 times, because the 10th term is 9 terms after the first term. If you wrote something like this, please distribute it out. And you should arrive here. Some of you may have started here and noticed this is my rate of change. That'd be like my slope in y equals mx plus b. This would be the a sub 0 term. So if I add 75 cents and go 1 term back. So let's look at this for our explicit formula. And look at how can I determine how many terms then are in this sequence. So pause the video, see if you can figure out how many terms there are using this explicit formula that we just came up with. So this is like the term a sub n, but I don't really know what n is. So if I know the value of that term, plug that in, should equal negative 0.75. Now I want to know what number term that is, plus 100.5. So all I need to do is plug in that value of the nth term, and that should allow me to solve for n and figure out what term number that is. So if you subtract 100.75, divide by negative 0.75, you should get that that was the 60th term. So how long does it take? About 60 months or 5 years. No, the next question I want to address is really, how much did you pay over the life of the loan? So if you direct your attention to this first question, let's write this as a series using summation notation. So pause the video, see if you can think of what that summation notation would look like. So hopefully use the sigma. I'm starting at month 1. I'm finishing at month 60. So what we did at the previous page was pretty important. I needed to know how many terms there were. And then I'm adding together 60 terms for what sequence? That would be negative 0.75n plus 100.75. So insert that explicit formula. If I want to find the sum, yep, this is an arithmetic series. I kind of see that y equals mx plus b. So now I can use that equation that we talked about, plug these values into that formula, and let's see what answer you're coming up with. So to find the sum of the first 60 terms, I can pair them off. There would be 30 pairs. Each of those pairs should add to, if I take the first term, so I could plug in 1 for n into my explicit formula, or this is a sub 1, right? You already know it, 100. And then I want to add on a sub 60. Well, that's the value of the 60th term. So I'd have 30 pairs that would add to 155.75. Punch that into your calculator. And you should get the total sum you paid back. So there was about $672.50 of interest on your $4,000 loan. Now I'm going to let you video watchers in on a little secret here. You can check your answer on your calculator. I'll show you how to do it. So on your calculator, if you go to math, and then it'd be option 0. So math 0. Gives you the summation notation. And this is if you have the new operating system. If you don't have the new operating system, ask me. There's still a way to do this. It's just a few more keystrokes. So with the new operating system, I want to go from what, 1 to 60. And then my explicit formula was negative 0.75 n, or x, plus 100.75. And if you hit enter, there it is. There's your answer. So certainly on a test, I can't let you use your graphing calculator for this part, but it's a great tool to check answers on your homework.